Welcome to Unit 3. This is day 1 of Unit 3, Trigonometry. This is going to be the first of 2 videos. This video is focusing on what a radian is, how to convert a radian to degree, and vice versa, how to go from degree to radian. And also, how to calculate the length of an arc, which we've done before using degrees. Instead of using degrees, we would use radian. And there's a little formula we're going to use for that. First, we have to define what a radian is. So a radian, simply put, is the length of the radius wrapped around the circle. And there's only a set amount of these we can wrap around the circle. It looks like maybe, I don't know, 1, 2, 3, 4, maybe about 6 of these will wrap around a circle. But if you want to get precise, a radian, if you go halfway around the circle, it's just a little bit over 3. In fact, it's 3.14, which, if you recognize that number, is pi. And why is it pi? Well, because the circumference of a circle is 2 pi r. So if I go twice that, that's 2 pi. So half of that's going to be 1 pi. So you'll see that right there is halfway around the circle is exactly pi radians. So we actually can convert from degree to radians using 180 and pi. And I have a little cheat sheet here, formula for you. If I want to go from an angle to a degree, if I want to go from degree to radians, I'm going to multiply that degree by pi divided by 180. And if I want to go from radians to degrees, I'm going to multiply that radian by 180 divided by pi. And let me show you how to use that. So just kind of using these are all degrees around the circle. You'll notice that this says 420 and negative 225. So don't worry about the fact that they're not always going to be between 0 and 360 right now. Let's just focus on the number. In order to get that degree converted to a radian, I would have to multiply that by pi divided by 180. So, just pull out the calculator. You all know where pi is. 20. Let me clear that out first. If you go 27 times pi divided by 180, because that fraction is just division, you're going to get about 0.4712, etc., radians. We don't typically express radians as a decimal, though. So what we're going to do instead is we're just going to say 27 divided by 180 and not type pi in. Press enter. And you'll notice it's either going to be a repeating decimal or some sort of decimal that ends, so we can make a fraction out of that. And to do that, we're going to press math, enter. Math, convert that to a fraction. And you notice that fraction says 3 over 20. So, when you write the work down, or rather when you use your calculator, you're only going to type in 27 divided by 180. You're going to leave the pi alone. And 27 divided by 180 reduces to 3 over 20. Now, where does the pi go? You just write it. So you put the pi on top of the fraction, and we're going to call that degree 3 pi divided by 20. So divide the numbers, reduce the fraction, put the pi on top. Let's try it with 420. 420 divided by 180. It says 2.3333 repeating. Again, that's a repeating decimal, so that's going to be able to make a fraction. If you press math, enter, we can convert that to 7 over 3. So the work that you'll put on your paper is you're going to multiply by pi over 180. You'll write that down. But only divide the two numbers. Don't type pi in calculator. That's doing too much work. So 420 divided by 180 is going to be 7 over 3. And just put the pi on top, and you've converted. So whether it has a number greater than 360, whether it's negative, right now, let's not worry about what to do with that. So, just continue the last 2. Pause the video. Try these last 2 on your own. And let me get these ready for you. All right, so hopefully you've taken a minute to pause. Let's check those. So negative 225 divided by 180. Is negative 1.25. Again, I'm going to convert that, and that's going to give me negative 5 over 4. So your answer is going to be negative 5. Put the pi on top, divided by 4. And let's check the last one, 270 divided by 180. $1.5. 1.5 converts to 3 over 2. So we'll do 3 over 2. And don't forget to put the pi on top. And there you have it. That's how you convert from degrees to radians, multiplied by pi over 180. All right, so when I want to go the other way, and I'm given radians already, and I want to figure out how many degrees that is, we're going to flip that fraction. Instead of saying pi divided by 180, we're going to do 180 divided by pi. So you'll notice that the radians typically are already written in fraction form. So what's going to happen is you have a pi on top, you have a pi on bottom. Those just cancel out. So we really just focus on the numbers. You know, we have a 2 and a 180 on the top and a 3 on the bottom. You're basically going to go in your calculator. You're going to say 2. Well, you can do the 180 last if you want, but it's 2/3 times 180. And we can go over here and kind of figure that out. Oops, 2/3 times 180. There we go. 2/3 times 180 is 120. So since the pi's are gone, this would just end up being 120 degrees. So that's in degree form. That's it. So just kind of keep that pattern going. Pause the video, try B, C, and D, and check back when you get them all, and we'll check the answers. All right, so just getting these set up. Oops. Yikes. There we go. So getting these set up, again, when you do times pi, 180 over pi to convert from radians to degrees, pi's cancel out. Let's do negative 4/5 times 180. Negative 4/5 times 180 is negative 144. Don't forget that degree symbol. Same thing with this one. Now, we don't have a number on top of pi, since it's just pi over 2. So what you want to do is always put a 1 as a placeholder. So that's going to be 1/2 times 180. Which, if half of 180 is just 180 divided by 2. So you can do it like that too. Half of 180 is going to be 90. So that's going to be 90 degrees. And let's try negative 11 pi over 6 times 180. So we're gonna do negative 11 over 6. We're going to times that by 180. And it'll be a negative number. Don't forget to put that negative symbol on there if it's there. And it says negative 330. And that concludes converting between degrees and radians and vice versa. So we talked about arc length before. You're used to seeing this formula, L equals 2 pi r times degree over 360. And you know, that's if I have a radius, and if I know the degree, I can plug it into that formula, get the arc length. Well, we can also do it with radian measure, and it turns out that if I do a little conversion here, let me talk about 2 pi divided by 360 first. You know, if I divide 2 and 360, that's going to be 1. 2 divided by 2 is 1. 360 divided by 2 is going to be 180. So if I actually convert that to 1 over 180 instead of 2 over 360, then what I'm going to have is this pi over 180. Well, you'll notice that we just converted from degree to radian, and we multiplied by pi over 180. So if I do the conversion, I can simply say the length is the radius times the radian. And we actually have a fancy formula. We call it S equals R theta. And S just is the symbol they're using for arc length in this form. So again, it's no different. It's length. And the theta, that's a Greek symbol. The theta here represents the degree, the angle. But instead of in degrees, the angle is in radians. Now, I rarely refer to it. I don't like that formula. I don't like the symbols. I usually just say L equals radius times radians and call it good. But that is the formula that you would see like in a textbook if you opened it up. So here's how you use it. So, you know, if you look at this, red flag being if you see the word radian or if you see a pi in there, that means that angle is in terms of radians. I want to find this length here. So this L represents the length. So that's your, let me just write length here. That's your S or your L. That's what I want to find. Now you'll notice this radian is the angle measure, and the 4 here represents the radius. So if I use that formula, let me use S and R theta just because it's easier to write. The S is going to be what A is. I don't know what A is. The radius is 4. And the theta is 7 pi over 8. Now, let's read the question first. It says, find the length of the arc round to the nearest hundredth. Well, we want to actually round it, which means we want to use pi. So we're going to go to this calculator, and we're going to type in pi to figure out, you know, about how long is that. So we're going to do 4. And let me just put it in parentheses so we can kind of group them together. That's 7 pi divided by 8. Radius times radians. And that's about 10.99557. You know, it says round to the nearest hundredth. Well, you know, that 5 is going to bump that up to 9, to a 0. So that really is going to be approximately, I'll just put a little approximately symbol, about 11 inches. Let's go over here. I want to get the length of W. Now W in this case is the length over here, not the one facing the degree, the angle over here. So we actually have to do a little bit of a subtraction first. To get this angle here, since I want to get this part, and around the circle is 2 pi radians, then this angle is going to be 2 pi minus 5 pi over 6. That's going to be what this one is here. So I'm going to, don't worry about typing pi and just do 2 minus 5 over 6. That says 1.1666 repeating. Press math, enter, enter. And that's going to say about 7/6 pi, or 7 over 6. So what we're going to say is 7 pi over 6. And that's going to be our radians. So using our formula, just plug in everything we have. S is going to be W. That's our length. Radius, in this case, is still 4. But our theta is going to be 7 pi over 6. So let's type that in. 4 times 7 pi over 6 is about 14.660. So my length W is, we'll say 14.66. And since that was in centimeters, cm, we'll put a little cm there. Very good. Try the next two problems, read through them. Part C and D don't give you a circle, but it's still the same formula. You're still using S equals R theta. So let's read the question. A circle has a radius of 5. There's R. Find the radian measure of the central angle that intercepts an arc length of 15 units. So arc length, that's L, which is your S. We're given actually the length and we're asked to go backwards. So we want to know what is the radian measure. Remember, that's our theta. So we don't know theta. So we're gonna just divide. S is going to be 15. So we'll say 15 equals 5 times theta. And to solve, that's just times. So to solve for that, we're going to divide. 15 divided by 5 is 3. This doesn't have pi. This is simply 3 radians. So that is going to be your answer. There's no units you got to use for radians. 3 equals theta. That's your answer. Try part D. Pause it first, so you can try it. All right, letter D. A circle has a radius of 18. Again, we're given the radius. Find the length of an arc. So we want to find the length. Length is your S, intercepted by a central angle measuring 2.9 radians. Again, there's no pi here, so it's just your theta is simply 2.9. So we have R, we have theta. Let's plug it in. S equals R theta. And 18 times 2.9 is 52.2. So that length is 52.2, and since we don't have units, it just says 18 units. We can write units or just leave off the unit if you want. I'm not that picky about it. .2 units. All right, that concludes part 1. This is just a short introduction to radians and arc length using radians. The next part is going to be talking about how to read the unit circle and kind of get some degrees from that. So hope this was helpful, and keep watching.